muted. Unmuted.
Hello. Yeah. So I guess let's get started with today's session. So like okay, and even okay. So before we get started, right? So someone Rachna asked to make her the presenter, right? So so just want to know what is the reason for making a presenter? So you want to share something or? Okay, fine. Fine, then we'll get started with today's session. So uh, before we get started, right? So guys, say I asked you yesterday to go through OLTP and OLAP differences, few more, right? So anyone like have browsed through that particular differences? So we'll just get started with that specific thing first on the OLTP versus OLAP, and then few more concepts on like data warehousing. So this is something we'll get started. So before we get started, right, so able to see the notepad and then able to hear me. So before we get started. Okay, fine. So can you add like a few more points or just repeat like what points you said yesterday, right? You can just add on to that particular point. So when we said OLTP versus OLAP, right? So basically under OLTP, you said few points basically yesterday, 4 points if I remember it correctly. And then on the OLAP, you said like 4 different points under the OLAP. So if I remember correctly, basically we were saying when I say OLTP, right? So this particular OLTP stores current data, and then when it comes to the OLAP, so it is going to stores, when it stores like say most recent, it might be a day or something, a day lag. So most recent and entire historical information, entire historical information. And then you said basically here it stores data, say I mean few gigs, or say for example, say around like data will be present in between, say for example 500 to like 700 gigabytes. And then whereas when it comes to here, so we said it will be storing in n terabytes, or say for example it stores data in petabytes. And what else you said here? So on the performance, you said the performance will be high, and then you said performance will be low. Performance has been the access speed, like to get data from that database, right? So that particular speed so will be slow. Right. So this is the one thing, and right, perfect. Thanks for your input. So basically here all the operations can be done. Select, insert, update, and then you do a delete operations there. And when it comes to here, so you are going to do select most of the time, and then daily you do a insert. So these are the 4 points which you stated yesterday. So as part of yesterday, right? So this is what you said basically. So now to get started, the first half we'll see on the OLTP OLAP few more differences from your perspective, and then probably we'll get into the other concepts on what is dimension or like some basic concepts. Okay, so fine, I got like a point basically. So many tables. Okay, 1 second. So Tarun says query select. Okay, that is done. Many tables and then less tables. So where you will have many tables, less tables, OLTP are not preferred. Controls fundamental business task. OLAP helps with.
OLTP has many tables, and OLAP has less tables for the data storage schema.
OLTP has more tables.
Yes,
Okay, OLAP has less tables.
exactly.
Okay, so is that Tarun?
Yes.
Okay, fine. Thanks for the inputs. Yeah. All right. So when I said like, I mean that more tables and like less tables, right? So that particular point, let me, I mean, put in a more technical word. So this particular systems, right? So you might have heard normalized or normalization way back, but say here you'll find more number of tables. We'll understand what is this particular normalization. And the same thing here, we'll have less number of tables. The reason is here the tables will be denormalized. So what is normalized? What is denormalized? Like pure technical concept. So we'll be just discussing that, and then few more inputs I got from so others. Let me see that one. Now OLTP is a single source and OLAP multi-source. Okay, OLTP controls fundamental business tasks. OLAP helps with planning, problem solving. Okay. Okay, fine. So at least good. I see a lot of inputs from you. I think at least you spend some time browsing in Google. At least that is a good start. So let me tell you a few more differences between the
So
OLTP to.
processing speed is more for OLTP and
Yeah. The processing speed itself, we put in other word like performance. So if you look at this particular word here, so whatever you said, this is the same thing. The access speed, the performance, whatever, right? So the performance will be high because the customer interacts with this system, and it has to be well.
so and moreover coming to the source data, OLTP has operational and this one comes from OLTP, right? So OLTP
Fine.
is the operational data and OLAP is which is nothing but
Right.
something like
So
cultural.
historical.
Yeah, exactly.
Right. So that point also, yeah, in a different words, but yeah, we have stored that one. Stores current data. That is like, in other words, so it stores all your transaction by transaction data. Okay. Fine. So now few more points. Basically very simple. So good, like every one of you, right, spend some time. So really appreciate that. So now basically when it comes to this OLTP, right? So what is the main purpose of this particular databases for the business? Basically is it is used for running the business. It is used for running the business. So how it helps in running the business or maintaining the business means it has to capture that transaction by transaction data. So by storing that particular transaction by transaction data, so what it helps basically is it helps in running the business. So on the same lines, when we say this particular thing, so when we say OLAP, why mainly this OLAP is designed basically, right? So OLAP, from the name itself, right? It is used for analytical, or it is used for analysis. It is used for analysis of business. So OLTP is used for running the business, and then OLAP is used for analyzing the business. For analyzing the business. And apart from this, so basically just try to understand here, on a day when you do 10 transactions, when you do 5 transactions, each of your transaction by time it gets stored here. So that is what, like transaction by transaction data gets recorded here. So that particular transaction by transaction, right? So what I say basically is this particular system, OLTP system, is going to store your transaction by transaction, or in other words, it is going to store detailed data. It is going to store detailed data. So OLTP systems are going to store detailed data. So whereas when it comes to the OLAP system, right? So this particular OLAP system is going to store instead of a detail, right? So we can put in other words, very simple, as in I said yesterday, you do 10 transaction, the 10 transactions will be aggregated. It will be aggregated. So whenever we say aggregate, right? So what we say basically is summarized. So your OLAP system, right? In order to do analysis, you don't require the detailed information. So instead of that, what we do basically, we are going to store aggregated, or else, so we are going to store summarized information. So in the OLAP system, the data will be aggregated or summarized. And whereas in case of OLTP, so here you find that particular data as a detailed data. Fine. So this is fine basically. So now, at least you remembered some points, and then few more points we'll just try to understand basically is, so in case of this particular OLTP, right? So this particular systems, everyone just don't focus on, don't write any notes. I'll be sharing this videos. And the second thing for all the theoretical perspective. So yesterday I've shared some material. So that was a draft version. I mean, basically, we used to have a classroom sessions mostly, so everything was on board. So I've just have this particular material. This is a draft version. So I'm just daily updating. Probably by end of course you'll get the final version. So it has every concept in it. So whatever I teach basically. So this is written by some of the students. So all these particular things, whatever we discuss, will be covered here. So everyone during the session, right? Please request not to write anything. So everything I'll be sharing with you in a day or two. So as like the concept completes and you get that particular material as well as a video. So don't try to write. So just try to focus on the class. That's it. Okay. So now basically whenever we say normalization, right? So generally we follow this. I'm putting as a technical word, but let it be here. So we'll discuss this tomorrow. So we follow some modeling called ER modeling. And whenever it is a denormalized, in case of OLAP system, we follow a modeling called as dimension modeling. So this is the key thing to get started on our micro strategy basically. So this is where it has to start it. So we need to be good in understanding the dimension modeling. Fine. So apart from this, basically, so what others we require basically is, so generally, I mean, say, I think a lot of people have done, say, a background on, I think hopefully you are from like, say, some BTech or like some MCA, like those background, right? So generally, we had, say, for example, a DBMS, right? So everyone knows this particular thing. And after this, basically, so there is something called RDBMS. So database management system, relational database management system. And now you have ORDBMS wherein the OOPS integrated to that one. So now can someone from here, right? So just tell me. So initially during the starting days we have this one, and later from 1980s, say like all databases has moved into RDBMS. So any inputs basically, so when a DBMS is called as RDBMS. At least have you heard DBMS or RDBMS? DBMS has data defined in tables. How about in DBMS? So in case of DBMS also, right, so we have that data defined in the tables itself. But like there is a, I mean, a DBMS itself is called RDBMS when, say, some, okay, fine, let me, I mean, give a clue. It is extension of DBMS. That is what, why that extension, when that extension came, or on what basis that extension came. Okay, fine. A DBMS is called RDBMS like when it follows certain rules basically. So what are that rules? We don't require, but at least tell me who defined that particular rules.
DBA.
Not DBA. There is a person like you and me. There was a person, a famous
Architect.
mathematician. Huh?
Architect.
Architect. database will be an RDBMS, or it supports at least 7 rules or more than 7 rules, and Oracle is a database which supports all like 11 rules, and accordingly most of the databases as well. But so basically on a similar lines, so this is an example why we require basically is, so on a similar lines, when it comes to data warehouse, for data warehouse also, so when we say data warehouse, right, so this particular data warehouse, right, you have a data warehouse, and this particular data warehouse also, to be efficient, so there was a person like who has defined a data warehouse, and his name is like Bill Inman, in the say early 1990s or like late 1980s, right? So 1989, he has provided a definition for the data warehouse. So for the data warehouse, so this particular person, Bill Inman, is considered to be a father of data warehouse. He is considered to be a father of data warehouse. He has defined some set of rules. Okay, if any data warehouse, you define any data warehouse which is a database, if it follows these rules, then it will be efficient. Then it will be efficient. So what are that particular rules basically on which he has defined basic elements? So he tells that, so on a data warehouse, so if that particular data warehouse, whenever you define a data warehouse, just ensure that it should be, I'll explain you, it should be subject oriented, and apart from that, so I mean during the starting someone put like single system and then like collection of all these particular systems. It's like integrated, and then it should be non it should be non-volatile, and then it should possess a time. Uh, no, these are not related to DBMS. This is related to data warehouse. So RDBMS, just to give an input, I have said you basically. So these rules are for RDBMS. Like RDBMS is not our scope; it is our out of scope. Basically, for people who are learning database, that is required. So just I want to tell is, so DBMS. Whenever we say DBMS, right? So that particular DBMS, why they have moved into RDBMS means it has to be efficient. On a similar lines, in order for a data warehouse to be efficient, there is a person similar to EF code who has defined for RDBMS. So there is a similar person, Bill Inman, who defined some set of rules for the data warehouse. So this person, Bill Inman, is the first to define data warehouse, and as per his definition, he says data warehouse should be a subject-oriented, integrated, non-volatile, and time variance collection of data. So whenever if someone asks your definition of data warehouse, you can just combine this one. So data warehouse is a collection of subject-oriented, integrated, non-volatile, and time variance collection of data. Alright, so what are all these particular points? We'll just discuss. So when we say, okay, it is a subject-oriented, integrated, non-volatile, and then time variance. Alright, so when I say this particular select and insert, so this particular thing comes and fits here. So here we don't update. So instead of like duplicating our points, right, I'm just putting it like where it fits in. So this is the point, and then on a similar lines I'm just going here. So here you what I do basically, I said subject oriented. So when I say subject oriented, this system will be an application oriented. So apart from application oriented, the second point I said it is integrated, right? So here it is, I put as independent system. So every system will be a independent system. And third one, basically I have a volatile, and there I put say, I mean here it is a volatile, there non-volatile. The reason it is volatile basically is it supports all things like updates and deletes are also performed here. And apart from that, like you have a time variance, So I'm just providing there, say for example, non-time variance. So non-time variance. So these are like few technical things, like whenever someone asks you in an interview, right? So whatever points you said, those are perfect, but I request you to tell this particular 4 points, because when a lot of people learn data warehouse, right? So generally they get into more technical and then learn this particular points: subject oriented, integrated, non-volatile, and time variance. So if someone asks you a differences between like OLTP to OLAP, I just request you to state these particular differences: subject oriented, integrated, non-volatile, and time variance. What is this particular points means, we'll just see. So I'm just getting back to yesterday's diagram. So till this point, I think you have set the differences. So this is used for analyzing, or it stores like most recent and entire historical. It is an aggregated or summarized. It contains terabytes or petabytes of information. The performance will be low because there will be a lot of historical information. Very big tables will be present in the OLAP system. So hence the performance will be low. Fine. So till this point, you have any questions, you can ask me before we get on to the other points. So if you are good till this point, then probably we'll get to the other points. Okay, good. All right. So now moving on to the next set of points. So you have subject oriented, then you have integrated, and so on. So I'm just getting into say the diagram which we had yesterday. So on this particular thing, so just try to see. Basically, I'll just give very out of that particular points, right? So very simple thing is, we say when we say OLAP, it is an integrated. During starting also, we had one particular student who said this particular concept, but in a different way. So integrated means whenever you are getting data into data warehouse, right? So you are collecting data from all the source systems. You are just combining data from all these particular 5 or 30 systems, and you are just loading at a single repository, which is called as data warehouse. So once you store your complete enterprise data or complete business data at one single place or one single repository, it will be helpful to perform analysis, or like that analysis will be simpler or it will be better. So on that specific lines, right? So data warehouse should be integrated collection of all your source systems data. So this is what integrated means: all source systems you are combining using an ETL tool to load into data warehouse. So this is an integrated system, and here every system is a different. Loans is a different, FD is a different, brokerage is a different, and so on. So all these particular systems are independent. So hence when we have here integrated, I put here the word these are independent. Alright, and apart from that, in that same thing, so the second point, right? So this third point, basically, you already said basically. So here we are saying it is like, say, non-volatile, wherein I'll have select and insert itself. But whereas when it comes to this particular system, I'm saying this system is a volatile system. So under this particular volatile system, so it has like all these operations. So why the systems are volatile, and then why these particular systems are non-volatile means, so these systems require, or like this system, right, mainly designed by the business for performing the analysis, and this analysis is possible when you don't do updates. When you don't do updates, like, I mean, let me take an example and show you how the data will be present in OLAP system, and then how the data will be present in the OLTP, or like to understand that all operations are performed in OLTP, and like only select and insert. Why only select and insert in the OLAP system? That we'll understand using a simple example. Say for example, so I require your inputs here, guys. So just try to focus. Very simple thing. So on a day-to-day basis, you just do it. So I have a simple, say, customer table. So this particular customer table has few columns in it. Say for example, so I have a say for example a customer, or I'll put in a shortcut. So I have, say for example, customer ID, and then I do have customer name, and then basically I do have, say for example, customer address. Say 01 A, he resides basically in Hyderabad as well. So 02, so this particular person name is B, he is going to reside in Bangalore. And then I have 03, say for example C, and then this guy is going to reside in Chennai as well. And similarly there is a person 4, then say for example D, and then he is going to reside in Delhi, assume. So this is a table, and this particular table, assume for a minute, I have an OLTP system. So I have this particular table in OLTP system, and say for example, assume the same table you have an OLAP system, assume. So you have in a OLAP system the same table, right? Perfect. So once you have this particular table here, now just try to focus here. So now when a person definitely is not going to stay in a single location throughout his particular lifetime. So he moves from one place to another, city to other, one country to other, and so on. So on that line, say for example, one of a person who is in Chennai who got transferred to Hyderabad. So in case of OLTP system, what I do basically is I just come over here, and then I just go here, and then I'm going to update this one. So I'm going to overwrite what? Wherever I see customer ID as 3, instead of Chennai, what I do basically is I'm going to update this with a new address. And then same thing, after a few more days, that particular person again move to some other place, right, Pune or something. So on that lines, I'm going to update to Pune here. So within, like, say 2 years, initially he was in Chennai, then moved to Hyderabad, then moved to Pune. So every time he moved his particular address, I've updated it. So in this particular system, in the OLTP, what I'll have basically for customer 3 basically means I'll have only information that he's going to reside in Pune. He's going to reside in Pune. So only that specific information I'm going to have in my table. So whereas the same thing. So here I'm just updating it. If a new customer comes in, I do an insert. When someone wants to see how many customers are there, they are going to select. I want to delete some customer, I do from here basically. So all these operations can be performed in your OLTP system, in the OLTP. But same thing, when just I try to do the same thing here, like what is the problem? Let's try to see. So a person, say for example, he moved from Chennai, and then as I said, he moved to Hyderabad. I've overwritten Chennai to Hyderabad, and then after this, from, say for example, Hyderabad to Pune. And similarly, there are like 1 lakh customers, and out of these customers, a lot of persons keep changing, and then every time I'm going to update their particular address in my system. And once I do that specific thing, say for example, tomorrow, he's a customer from your bank, and then you're a bank manager, assume for a minute. And then when a customer applies for a loan, right? So do you check certain things, as in, how long is staying in the current residence, and prior to this one, what is his particular location history, and all other details, whether you are going to do some analysis before you issue him a loan, or directly is a customer of your bank, without any risk you are going to issue him a loan. So do you some analysis before issuing, or like that is not required, as is already a customer of your bank, and then you go ahead and issue him a loan? So can you elaborate more, Tarun? Required history? Yeah, we do need that historical data. So in order to issue him a loan or provide a loan approval and so on. Right, perfect, good. So in order to do that, yeah, that is required, good, perfect. So, but whereas when I try to look at this particular thing 03, I'm just getting his Pune only, because I've overwritten my older address with a newer one. So on that particular lines, never I can retrieve his particular older address. So what that does basically, when you overwrite or when you update, it is not going to help us in performing the analysis. It doesn't help us in performing the analysis. For that particular lines, what I do, how I define my OLAP systems basically is, so initially he was in Chennai, and then basically I store some particular date. Say for example, I will add up here some extra columns as for example, so from which particular date he is there, and then I put another column called as end date, and then I'm going to store this particular details. For the same customer, I write some dates here. Say for example, in Chennai, he has resided from, say for example, 23/11, say for example 2012, and then initially I don't know till which time he'll be there, so I've just provided some high values like this. And then when he moved out, say in the 2014 he has moved out, so then what I've done basically is, so I've just provided here, say for example 28, then 12, and then say 2014 he was there, and post which the same person who is from, I mean his ID is same, but now he has moved to a different location, and in that particular location is residing from 29/12/2014 to say in 2017, say for example 21/11/2016, and then say for example 03, and then C, and this particular person now is in Pune from, say for example 22/11/2016 till date, say for example. So I have this particular information now. So when you have this historical information, one thing, there are a lot of duplicates, that is fine, but the bottom line, this particular database is used for doing the analysis. So when you have this particular information, is it helping you to perform analysis? Means yes, I can see his current, I can see his past, and then I can see his past to past as well. So this is what required in case of OLAP system. So in case of OLAP system, just one point, you don't update. Always you just try to insert up a new data, and then so once you insert the data for performing analysis, you are going to select it. So as you don't do any updates to this particular database, it helps in analysis, and that is what the point here, technical point we have just put as, say these systems are volatile, means they change very rapidly because 1 billion customers performing transaction, at the same time lakhs of customers are performing, everything gets updated. So that is where the volatile. So your OLTP systems will be volatile, and whereas when it comes to OLAP, so it will be non-volatile, because here you do only select and insert operations. Alright, so till this point, right? So good on like integrated and non-volatile. Okay, perfect. Thank you. So now moving on to the next point. So on the time variance. So here you have time variance, there you have non-time variance. So very simple point on time variance, on non-time variance. So when in case of time variance, mean basically I want to based on certain time frame. Time frame means, so I want to analyze my this quarter. Say for example, so I'm in 2017 Q1, right? So I want to analyze what is my 2016 Q4 and then 2016 Q3. So I want to see, or I want to analyze my last two quarters, or else I want to analyze last year in 2016 how was my quarter one, how was my quarter one. So at the starting of this month in January 4th or like 2nd, I need to analyze what is my previous quarter and previous year same quarter, means 2016 Q1, how were my profits, and then just in 2016 how is my Q4. So this information I need to analyze so that I set up certain rules for my coming quarter. So okay, these are my plans I have to do which improves my business. So that is what I need to take care. So in order to do that particular planning or set up certain initiatives for this particular quarter, first I have to analyze my previous information. So here I want to get information based on the quarter. So this quarter and previous quarter. So your data warehouse or OLAP system should be defined in such a way that it has to pull data based on certain time frame. Means current month, previous month, current quarter, previous quarter, current year, previous year, and so on. So I need to get data based on certain time frame, and that is possible only in the OLAP system. The reason basically is in the OLAP system itself we maintain the entire historical information, but whereas when it comes to your OLTP system, so we said it is going to store data. So this particular stores current data, but how many days? Basically it stores data of, say for example, 30 days, say to maximum 90 days. So you don't get data for previous quarter or previous year. So on that particular system you cannot perform any time series analysis here. So in case of OLTP systems, whereas that thing is possible in OLAP as it stores the entire historical information. So that is what the point. So you have your system should be capable to pull the data based on time frames so that you can analyze the data better. So that we have a concept called transformations. Basically during that you will understand, we'll have an hour session, so how this particular time series helps in performing the analysis. Then apart from this, the other one, the last one, basically from whatever he has defined, this particular 4 points is subject oriented. So when I say subject oriented, so this subject oriented, and there I am saying that it is an application oriented. So here I said application oriented. So what does that mean basically is, so when you get into Word document, so in this particular document, so here it stores data related to loans, it stores data related to insurance, it stores data related to brokerage, it stores data related to credit card, FD processing, and so on. So once the transaction gets stored here, so just try to understand here. So when you store the data in the OLAP system or in the data warehouse, so you don't here assume you have a customer table in this particular source system 1. Same customer table in other table, source system 2, customer table in source system 3, customer in other one, customer in other one. So in all 30 systems, you'll have customer tables. And all that particular customer tables, in each system, you'll have 3-4 customer tables. That is what like normalized and denormalized, we'll get there. So here, in order to store customer tables, I'll maintain 3-4 tables here. Same here, 3-4 tables for storing customer details, then here, and so on. So in 30 tables or 30 source systems, I'll store, say in each system I'm storing 3 tables to store customer data. So in that particular case I have 90 tables in different source systems. But when I load the data into data warehouse, what I do basically is I will store that customer as one subject, or else one single table I will store as customer table, and I load the data from all the systems into that single customer table. So I am creating here customer as one subject, and then I am storing all the data from all the source systems into one single table. Similarly, if you have any particular information related to, say for example, time, year, quarter, month, all these things here you'll have multiple information, date, which month, which week, and which year, so on. So all this particular information from all your systems you store in one single table, which is, say for example, a time table in which you store all years, quarters, months, days, everything at one single table, and you provide that table name as time. And then apart from that, so you do have products, or like you have geography, you have sales, all these things here it will be present in multiple tables. So all that particular thing you just come over here and then store that in a single big table. So once you store that information, okay, customer information, then say product information, time information, geographical information, and so on, it helps in faster analysis, or it helps in better analysis. So whenever you load the data into data warehouse, right, So that particular thing, right? So you have to store the data in subjects, whereas here you store the data in application. Each application you store different data, whereas here you store the data in a form of subjects so that it helps in faster analysis. So we'll see how the data warehouse looks like everything in a coming sessions wherein you clearly understand more on that. But just try to understand here, if you have multiple customer tables, you combine that, load into a single table, a customer. So that table I'm putting a technical word subject. Then time, that particular table stores all the time related information. Geography, which stores all your geographical related information and so on. So this is how the tables are defined in the data warehouse. So what Bill Inmon says is, if you design your data warehouse such that if it is a subject oriented, it is an integrated collection, and then it has to have non-volatile, and then it should have that time variance nature. So once it has all these things, your data warehouse will be efficient. Your data warehouse will be efficient. And this is a person who is first to define data warehouse in 1990s, and then that person is called father of data warehouse. So hence a lot of people, right, when we say what is data warehouse, so this is what the answer everyone provides. So data warehouse is a subject oriented, integrated, non-volatile and time variance collection of data. So clear on all these particular points, and when someone asks you what is data warehouse, you also just from now you need to tell this only. So data warehouse is a subject oriented, integrated, non-volatile and time variance collection of data. So there's a question from Tarun, why? Yes or like why? I mean, I didn't understood that. Okay, yes. Okay, fine. Perfect. So now moving on to say some more points here. So I mean, now if you look, I mean, the thing is now we are learning a lot of differences. By chance, if someone asks you in an interview, right, what are differences between OLTP, OLAP? Don't tell all points, like all these particular 10 points, because it may take 2-3 minutes. Basically, the interviewer gets bored, because in BTech or like something, right, if you know certain question, right, we just keep on writing the entire chapter for it, right? So here that doesn't make sense. So just you have to be straight to the point. So at least from this particular 10-11 points, pick up 4-5 points, and I say basically this will be the better points, as this is what you define a data warehouse, or else I provide something from here till down, all are technical points, and these are general points. You can provide a few points here and then 1 or 2 points from here, but most of the points, at least 3-4 points from the down. So this is how you need to present to an interviewer. Don't tell all 11 here, 11 here, right? So this for your understanding I am telling, and what is required for us is we don't require OLTP, we require OLAP, because this is where we start our reporting. So in order to know that one, we are just learning, why we require this system. So apart from that, we said something called denormalized, and then a dimension modeling here. So this is the key thing for us, so that we'll get started tomorrow, this dimension modeling. For some time, we'll just try to understand what is normalized and then what is denormalized. So anyone, before we get started, right, anyone want to provide some inputs? At least have you heard that normalization or denormalization earlier? So have you heard that? Yes, no, at least tell that one. Then we'll get into the details onto the normalization and denormalization, because normalization is very important in every interview. They'll ask you what is normalization. So you haven't heard, Tarun. Okay, how about others?
Normalization is with many tables with many relationships, and denormalization is like few tables with less relationship.
Okay. Who is that?
Micros.
So is it Kiran who is talking?
Yes.
Okay, okay, fine. Okay. Fine, Kiran, yeah. Fine. Anyone just want to add to Kiran, what Kiran said, or you have a different opinion as such, you can provide that. So everyone agrees with what Kiran says.
Pradeep here.
Yeah, Pradeep.
Normally, normalization means we have a, if suppose if you have a details of the customer
Hmm.
regarding his name and address and his job.
Hmm.
In normalization, we have a, it will split into different tables, like his address is in another table.
Okay.
Where come to denormalization, everything will be under same table, and
Okay.
also it has the duplicate records.
Okay. So fine. I mean, good. Yeah, Pradeep. If I mean, I understand your points correct. Like denormalization means the table will contain lot of duplicate values, and normalization means so basically we are going to reduce that particular duplicates.
Yeah, exactly. Data integrity.
Okay. Data integrity. Okay, fine. So data. Okay, fine. I mean, we'll get into details now. So thanks both Kiran and say Pradeep for giving inputs. So now again we'll take one example and probably we'll see for another 10 minutes, probably the last session, because dimension modeling will start tomorrow. So this is very important. So just try to understand. So we'll take an example. From that particular example, we'll just try to understand what they are saying. So just try to understand here. I have one table which has basically, for example, I take from whatever we are working. So I have something called category as one particular table. So under which CAT means category, just assume. I have something called category ID, and then basically I have category underscore, say for example, description. All this in single table. So I provide a table called as product table. So in my project, I have a table called product table. So, and this particular product table has different columns. So what are those columns? Basically means I have a category ID and then category description, and then on a similar lines I have subcategory underscore ID, and then say I have subcategory underscore description, and then I do have item ID, and then I do have item underscore description. So this is where I have my say a list of columns in my particular project under product table. And when I say categories, right, so under categories I'm just providing some particular example. Say for example, I see electronics. So electronics as one particular category in my particular store, and similarly I have say for example, so another particular category, so wherein I mean which is related to, say for example, books, and then another category, and so on, basically. Fine. So we'll just take these two examples here. So 01, then I have electronics here, and under electronics, right, so definitely we'll have multiple classifications, like you will have laptops, you'll have mobiles, then you'll have I mean lot of other things like DVD players, washing machines, and so on, basically. So on that lines, I'm just providing. So on this particular thing, I have an ID. Say for example, I'm just starting up with 101. So wherein, say for example, I have something called mobiles. So under mobiles, basically, there will be only one type of mobile, or there will be multiple types of mobiles. Under mobiles category, so there will be only one, or like there will be multiple. So there will be multiple, right? So again in one brand, when you take multiple brands, in one brand, again there will be multiple models. There will be multiple models. So I just don't want to name anything. Say for example, I have this particular mobile with, say for example, model, some for example, one assume for a minute. And then similarly, I may have another particular information for which I need to get all the specific thing. So 01 electronics, and then under the same mobiles category, say for example, now the model changes. So 002, and this is say for example model 2 or mobile model 2. And on a similar lines, basically I may have different things. Right. So on that specific lines, I have say only 5 different models in my particular stores under mobile system. So on that specific thing, so I have say for example 03, and then say for example 04, then 05, then 06. I have 6 different mobile models assume. So I'm like a vendor of only one product which has 6 different models in it. And this is say for example that particular model numbers here, model 5, and then say for example model 6. And the same electronics, do I have any other categories also, or I don't have any other categories here? I mean, so any particular store you go to electronics section, so do you find any other things apart from mobiles? So assume that you see laptop. So under laptop, I'm just starting from say for example 2001, and then this is something say for example model 1. And similarly, right, there might be again multiple models under it, right? So all these particular models, right? So for all these particular models, you need to have this particular information loaded in this particular table. So in which all these are laptop, but again the laptop model changes. The laptop model changes, and accordingly the ID is going to change. Each of that will be provided with a different ID here. So for example, so this is my model 1, and then I do have model 2, and then I do have model 3, and then I do have model 4, and then I do have model 5. And on similar lines, say for example, under same electronics, you may have like washing machines, you may have various other things. Yes or no? Agree everyone? So in this way, what you look at this particular table, like fine, I've written some particular sample data listed here, but looking at this table, so what do you feel is a problem here? What is a problem, or like what is that like you see here now? So there are a lot of, I mean, I've written only 5-6 models, but generally you know that in any particular store you find a lot of things like this and a lot of models in other words. So what is that problem you are seeing in this particular table? Can someone tell me? So in this particular table, now you could see some specific data. So Vamshi said he is able to see repetitive data. Okay. Repetitive data for what? What and what columns? You are seeing repetitive data. So is that particular data for item? So for item ID you are seeing repeated data. So for item also, or for category and subcategory you are seeing repeated data, or you are seeing for item? So question here is, are you able to see repeated data for category and then subcategory, or else for item also? Again I show you the table. Category and subcategory. Okay, no item ID. Fine, perfect, good. Good. Yeah, fine. Thanks all for your input. So till this point, if you look at this one, so you look at this one, 01 electronics, right, is repeated how many times? How many items you have? Say for example, 10,000 items you have, or in Amazon you take 1 million items, right? So all that particular things, right, this electronics has to be repeated. So that much duplicates you are maintaining, and forget about it. So when you come to item, right, so under mobiles there might be 500 different categories under mobiles, under laptops 100 different models. So for all that particular things, basically what is happening, 01 mobiles is getting repeated, 02 laptops is getting repeated, on tabs you do have different things. So on a similar lines, 03 tab is also getting repeated. So there is a lot of repeated data in this particular table. Agree everyone? So you have a lot of duplicates for category and then subcategory. So whenever we say a table as denormalized, so this is how the denormalized tables will look like. It will contain lot of duplicates. It will contain lot of duplicates. But what is the problem of this particular table? If the size of this particular table becomes very huge, then what is the problem basically is when you try to retrieve the data, the problem that happens basically is, so it will be slow down, the performance gets degraded. So on that particular lines, what we do basically is, as this particular table contains lot of duplicates, so what we do basically is, in order to improve the performance, we are going to normalize the table. So denormalized table means duplicates. It contains lot of duplicates in it. And what is normalization means? It is a process. Normalization is a process of eliminating duplicates from the table. It is a process of eliminating duplicates from the table. So that particular process of eliminating duplicates is done how basically? We'll just try to understand it. So now that is a normalized table, right? So when you want to, same thing, the same table, you want to normalize, then how you design basically, just try to understand here. So normalize means I'm going to store one table for category ID and then say for example category description, and then I create another table wherein I load only subcategory ID and then say for example subcategory underscore description, and basically I create another table in which I store item ID and then I'm going to store item description here. Okay, so what I have done basically is that single table I break down into three different tables. Like one category table, the other one as a subcategory table, the other one as a item table. So I break down one single table into multiple smaller tables. Why I'm breaking this basically is to remove this duplication. How I'm removing that duplication, just try to focus here. I have something called 01 here, and in 01 I have something called, so I'm just providing the same thing, electronics, and then 02 I was having say books. Under that I'm just providing that same books, and when it comes to the category, so I have something, say for example I've started with 101 I guess, yep. So 101 I'm just providing 101, and then say for example I have mobiles, and then say for example 102 I provided say for example laptops, and then similarly so 103 I'm just providing say for example a tab, and then similar lines. So I'm just starting 201 for books, wherein I have something called books which relates to sports, and then say for example 202 which belongs to arts, say for example 203 which belongs to literature, and so on basically, and different categories under it, fine. And similarly for the item, so I have provided 1001, and this is for say for example model 1, and then I have provided say for example 1002, say for example a model 2, sorry, yeah, model 1, and then say for example model 2. In this way, assume I have many different things, 6 models assume. So whatever I have it. So now assume like you fill rest of the table on your own, assume for a minute. So now if you look at this particular tables, so I'm not maintaining one single table, but in order to load that data, I'm just break that particular table, and then I'm loading the data into 3 different tables. So now look at this particular tables. So now do you see any normalization here? No, sorry, any duplicates you are finding over here? So any duplicates Do you see here? So no, but again, right? So this particular table, what I say is not like the completed table basically. So normalization means a lot of persons say same thing. It is a process of eliminating duplicates. Till that point is correct, and they break table into smaller tables. Fine. Till that point, the definition will not complete. So the definition completes. If you look at this particular three tables, look at the table 1, table 2, table 3. Three different tables here. So when you look at this particular three different tables, so then the question here is, between these three tables, is there any relationship? Is there any relationship? So that is a key point. So now people who don't know SQL, who doesn't know what is it, so very simple. The question here is, so I want to find out what are the subcategories that fall under category. So what are the list of subcategories? Means whenever I want information, I need to get these three. These three for electronics. So I want to get list of subcategories which are present under electronics category. So or else I want to find out list of say subcategories which fall under books category. So that is what information I require. So to get that information, so do we see I mean, is that particular query, whatever I said, right, is that achievable with like the sort of tables I have three different tables, or that is not possible with whatever design of tables I have done now? So it is possible, not possible? Tarun says possible, and how about others?
What was the question, Srini?
The question, Kiran, is so using these tables, I have two different tables, assume for a minute. Out of this particular two tables, what is my requirement is, I want to find out, or else in simple, I want to create a report which gives me what are categories which are okay, so under electronics category. What I want is, under electronic categories, I want to list the, so I want to get all the list of subcategories which are present under electronics category. So clear on question. So this is my requirement. So I want to get the list of subcategories under electronics category with this particular two tables. So very simple thing, either yes or no, only two options. You can provide that
No.
inputs. No. Okay, how about others? No. Okay, two no's. One, two, and then we have possible, equal thing. So a couple of no's. I say, two no's, and then say, two yes. So how about others? Just provide one or two inputs. No. Okay. So fine, then we'll go with majority, whatever is stated. No, no, no. Right, so the answer is also no. The reason basically, right, between these two tables, there doesn't exist relationship. There doesn't exist any relationship in order to understand, okay, this categories belongs, or this subcategories belongs to electronics. this particular thing belongs to books, or this belongs to mobiles, and the other one belongs to laptops and so on. Say for example, I'm just telling you an example, just try to see basically here. So 2000, okay, let me know. 1100, this is for the laptop one, 1101 for laptop second model, 1102 for say for example laptop 3, and basically similarly 1200 for tab model 1, say on a similar lines, say for example 1201 for a tab 2, 1202 for say for example a tab 3. Alright, perfect. So once you go here, so if you look at this specific thing, so there is no relation between any three tables, and you cannot get data when you don't have relationship. So in order to get data, right, so what we need to do is very simple. People who don't know on any basic SQL also very simple, you can figure it out here. So you have a category table and you have a subcategory table. So there should be a relationship between these two tables, for which I just come over here, and then what I do basically is I'm going to have my category ID defined here, and then basically what I do is I provide here 01, and then I provide here one more 01, and then a 01 here, and then for this particular sports, as it comes under books, I'm just providing 02, and on a similar lines 02, and then say here also I'm providing 02. Now if you look at these two tables, are they related? Yes, they are related. How basically is, so category ID from category table, and then you look at category ID and subcategory table, right? These two are related. Basically, now the same question, if I want to find out list of subcategories which are present under electronics. Then system comes to this table and it understands electronics means 01. So it is going to bring all the subcategories which has 01 ID, So once it gets all the subcategories with 01 ID, so do we get all the list of subcategories? Yes or no? So now after changing this table, is it possible or not possible? Yes. Now there is a relationship exists between them. So you get the data. Perfect. So similar lines, these two tables should be related. Now again a simple question. Just think and just tell me. So I just come over here, and then what I do is I have my subcategory ID here. Under my subcategory ID, so this is for the mobiles, right? I want to identify mobiles. So for all mobiles, it should be what? It should be 101. So for all this particular thing, it should be 101. And for all laptops, it should be 102 and so on. So in this way, now just try to understand here. So guys, like very simple question, but don't say like you need to answer fast and then tell it fast. So just think and then tell me. Right. So what is that I want basically is I have here 102. Fine. And similarly here these are my related to my tab, for which I am just providing 103, and then say for example 103, and then I'm providing here 103. So now if you look at this particular two tables, is these two tables related means? Yes, they are related. I want to find out all the items which are present under laptops. Is that possible means? Yes. What I need to do? For laptops, what is ID? 102. So here whatever you see with 102, all are the items present under this one. So that is straightforward. Similar like earlier example. But now the question here is, just try to understand, under electronics, I want to list all the items. So under electronics, I want to find out all list of items. So there are items is present here, and that electronics is present here. So do I get that information? So the question here is, I want to find out all the list of items which come under electronics category. So is that possible? tables. I don't add any columns, no columns. The tables remains as it is, and then I want you to tell me whether we'll get data or we don't get data. Simple, yes or no, that's it again. So couple of S's. So about others? 3 years. So at least for a couple of things, okay, 4. One more person. One more means from a different person I'm expecting. Okay, fine. Fine, all S, and yeah, the answer is also correct. So basically between this table and this table there is no direct relationship. There is no direct relationship, but now this table and this table are related using the subcategory table. First what it does, it comes to electronics, right? It goes to here 0 1. It takes that 0 1 and then it is going to search all 0 1. For all that 0 1s, it has IDs 101, 102, 103. It comes here 101, 102, 103. All that things it is going to bring. So between two tables, if there is a relationship, then it is called direct relationship. You have a direct relationship between two tables. So now between category to subcategory, direct relationship. Between subcategory to item, direct. From item to subcategory, to category. From item table to category, there is an indirect relationship. There is a indirect relationship. So they are related indirectly using the subcategory table, using the subcategory. So that point is clear, and whatever answer you said is perfect. But generally when like say Kiran and then probably Pradeep, when you said on normalization, so just want to add like few more words to it basically. So when someone asks normalization, so what we need to say basically is, so normalize, if you look at this also, here do you see a duplicates 0 1 0 1 0 2 0 2 101 getting repeated 103, but here what is happening when you normalize means the duplicates are getting reduced. If you look at here, electronics is repeating 1000 times. So these things you don't see these particular things. You don't see laptops, you don't see getting repeated. So normalization is a process of eliminating duplicates. Eliminating duplicates by breaking a large table into smaller tables, or splitting a large table into smaller table and establishing relationship between them using this is called primary key, this is called foreign key. So what is that? Technical things we'll see in a couple of sessions. So this is very important. So if someone asks you, very simple, normalization is a process of eliminating duplicates by splitting a large table into smaller tables and establishing a relationship between them by using primary keys and foreign keys. So you just tell all that particular point, that is a perfect answer for the normalization. Questions? You understand duplicate will be reduced and then the data will be faster. So any question on normalization point and denormalization? Denormalization, duplicates. When you look lot of duplicates, it is a denormalized, and if it is degrading the performance, you go ahead and normalize it, and this is how you normalize. And then we took an example to say that specific. So any questions, anyone, before we wind up for the day? Okay, fine. So you don't have any questions. So say for example, one request, basically everyone, right? So you can just send your details basically. So to this email ID. So I'm just typing in that to this email ID. I want your name, and then say for example name and your specific number, generally preferably say WhatsApp number or something. So name, number. So basically uh, and I want a reference like when yeah. Okay, so I want this details sent to this particular, not for persons who join from classroom. So for classroom, you'll have a person there
Sir,
who knows it. Yeah.
సార్ ఇది ఇక్కడ
Yes.
స్టూడెంట్ ఒక డౌట్ ఉందండి సార్ ఒకసారి మాట్లాడండి.
Okay, 1 minute. I mean, a person who is in classroom, right? Just give a minute. So basically, all who have joined here, I want this your name, number, and reference. I'll just add your, sorry, I missed out one. Basically, there only anyhow you'll see an email. That only you do it. But yeah, I get your email ID from there. Basically is I will just share you the documents and then the basically the videos whatever we are going through, right? So that particular videos also I'll be sharing it. But once I receive this particular thing, so probably everyone who are attending the session, so today take a minute or tomorrow morning, so and then send me the details of this particular thing. So based on that, I mean I'll start tomorrow so that makes sense. Pradeep is very fast. Already he has shared details. So I request everyone to send it, and people who don't have any further questions, right? So they can just drop off. We'll just continue. I mean, a little bit early, basically 9 a.m. I mean, today the classroom guys came little bit late. We had the 10 minutes delay. I'll just inform them today. So you guys started 9:30 so that we can complete most of the, I mean, by 11 o'clock, 1.5 hour, we can have effective session. Fine then, thanks all, I mean, who are leaving and who have doubts, you can just stay back. And yeah, you can continue with your question from classroom over there. Yeah, please go ahead. From classroom, right? What question you have, you can ask me.
అడుగు ఇప్పుడు నాకు చెప్పు నేను చెప్తాను సార్.
ఆర్గనైజేషన్లో కూడా లిమిటేషన్స్ ఉన్నాయి కదా, రిపీటెడ్ డేటా ఉంది కదా, అలా కాకుండా ఒకటే 101 రాకుండా 101 వచ్చేటట్టుగా ఉంటుందా?
సార్ హలో, ఇది కింద వచ్చే లైన్ లో వచ్చేసరికి నార్మలైజర్ లో వచ్చేసరికి డేటా అనేది డూప్లికేట్స్ అనేది కాకుండా వస్తాయా?
డూప్లికేట్స్ అనేది కాకుండా రావు. సో ఈ బేసికలీ 101 ఈ 101 ఇవన్నీ కూడా డూప్లికేట్సే. సో మనం ఏం చెప్తున్నామంటే నార్మలైజేషన్ అనేది డూప్లికేట్స్ ని మొత్తానికి రిమూవ్ చేయదు, బట్ ఏంటి అంటే డూప్లికేట్స్ ని ఎలిమినేట్ చేస్తుంది. ఇక్కడ ఉన్న ఎలక్ట్రానిక్స్ మూవీస్ ని ఎలిమినేట్ చేస్తుంది, బట్ ఈస్ అనేది రిపీట్ అవుతాయి యాజ్ ఇట్ ఈస్ గా. మీరు అన్నట్టు ఇప్పుడు ఇక్కడ 101 కానీ 102 కానీ ఇవన్నీ కూడా రిపీట్ అవుతాయి. నార్మలైజేషన్ రిమూవ్ చేయదు, ఎందుకంటే ఈ కాలం లేకుండా డూప్లికేట్స్ లేకుండా మనకి రిలేషన్షిప్ అనేది టూ టేబుల్స్ మధ్యలో ఎస్టాబ్లిష్ అవ్వదు అన్నట్టు. నార్మలైజేషన్ చేసినప్పుడు కూడా నేను మీకు లైక్ ప్రాబ్లీ ఇంకో 2-3 సెషన్స్ అయినాక చెప్తాను, అప్పుడు మీకు క్లారిటీగా ఉంటుంది. ఫారెన్ కి అంటే డూప్లికేట్స్ ని అలో చేస్తుంది, అండ్ డూప్లికేట్స్ ఉంటాయి. నార్మలైజ్ టేబుల్స్ లో కూడా ఫారెన్ కీస్ అనే కాలమ్స్ ఉంటాయి, దాంట్లో డూప్లికేట్స్ ఉంటాయి. సో ఇంకేమైనా స్పెసిఫిక్ క్వశ్చన్స్ ఉన్నాయా?
నో డౌట్ సార్, టోటల్ ఇన్ క్లాస్ రూమ్.
Okay, so anyone online, right? So do you have any questions? Fine then, in that case, we'll just complete it today. We'll just catch up tomorrow at sharp. So people who are in classroom, so just a request that you come by sharp 9 a.m. Okay then, thanks all for your time. Have a good day, and who joined from Hyderabad, and say a good night to everyone who joined from here. Bye.